Yeah. Yeah, nobody's there. Start करने के लिए.
People won't join on the meeting actually. They will say this later streaming.
Oh.
You have to listen.
Hello, everyone. So, good afternoon to all of you. Uh, if you have any, I'm sure you are all enjoying this course, I believe. Okay, and if you have any problem in understanding any topic, please do not hesitate to ask me, and I shall try to answer your questions and queries. Okay. Shivani, you are here. Just you have sent a question. Hi, Prashant. Good evening. How are you? Oh, thank you. So, you have any questions today, Prashant? Hi, Shivani. Yeah, I saw your questions. That is a bit general. Okay, about how to choose a complex for cancer study and how to do carry out work and right. Well, that I cannot tell you how to do it. Good evening. Basically, you have to understand, how cancer propagates, proliferation happens, and how to prevent it. That means basically how to use some metal complex that interacts with the DNA, and then what the replication is there that has to be stopped. For example, if you look into the story of cisplatin and its utility in cancer treatment, that gives a clue. When we want to use some of those things in cancer studies, we have to look for two type of interactions. One is covalent interaction, the other one is non-covalent interaction. Okay, so that means in the covalent interaction, maybe metal will bind to some of the donor moieties present on DNA or biological molecules. Okay, and then what happens? It will prevent further proliferation or growth. So there can be like covalent interaction. That means you should have vacant sites on the metal, and that should be in close vicinity to donor atoms from the DNA, and it binds. For example, if you look into cisplatin, you know that it's PTCl to NH3 twice. Okay, the moment you put into biological system, there are several options it has to bind to DNA molecule. How it does is, you can get rid of one water, one chlorine, and water can come, and now it will be cationic complex. Or you can also get rid of another chlorine with water and also form diaqua, a dicationic complex. Okay, or you can also form hydroxo-aqua complex or hydroxochloro complex, aqua chloro. Several options are there. So it can form. Once that is done, when H2O is there or Cl is there, that coordination site can be occupied by nitrogen or oxygen present in those molecules, mostly nitrogen. And then what happens? It binds. Once it binds, what happens? Further growth, proliferation can be halted. Or sometimes what happens? These molecules can, trigger or support some of the proteins that prevents proliferation, P50 or something like that. So there are several options. If it is non-covalent, what happens? Through some hydrogen bonding interactions, through some electronegative sites present on ligand atoms present on a complex, they can interact, and also they can also do this trick. That is called non-covalent interaction. Okay, so this is how cancer treatment can be looked into. And before that, we also make sure that when we have a complex in hand that can be used for cancer study, we have to look into two things. One is whether this compound is soluble in water, because aqueous biological system is in water medium, so they have to be soluble in water. or it should be sparingly soluble in water. Sometimes if it is soluble in some polar solvents in very small quantities also, it's fine, because we'll be taking in very, very minute quantities. On the other hand, the compound, whatever we are considering, what would happen after degradation? When degradation happens, the metal, is it highly carcinogenic, and it may cause, okay, other toxicity related to the body. And then the ligand, how it decomposes, because it is not going to stay forever. Probably life is 45 minutes or 1 hour or maybe 2 hours or something. Then your metal complex should degrade. When it degrades, what are the byproducts, whether they are harmful? If they are harmful, what would happen is they can go and deposit in kidneys, and there can be kidney failure. So before a patient can be cured from cancer treatment, the patient may die because of kidney failure. So all these things are associated, nephrotoxicity and all those things comes into picture. So we should make sure that our compound, when it degrades, it doesn't give very toxic, or it can easily water soluble or something, form neutral compounds that can come through urine or something. Okay, so like that, lot of aspects are there that one should look into before deciding a metal complex suitable for anti-tumor studies. Is that clear? So for that one, you have to see chemotherapeutic drugs and also how they perform and how they are interacting, and whether the primary effect is there, secondary effect is there. All aspects should be looked into it before you start designing your own complex for anti-tumor activity or cancer treatment. Okay. Any question? Is that clear, Shivani? Okay. If you have any other question, please, you can bother me. Okay. So how is your studies going on? What you are doing, Shivani? What you are studying? Oh, okay. How the bonding in iron pentacarbonyl can be explained using valence bond theory? Yes. So valence bond theory, if you take coordination number 5 complex, right? What is the hybridization you use? For example, if you are using for tetrahedral sp3 and square planar, you are using dsp2, okay, and then dsp3 you are using for trigonal bipyramidal. Okay, so this is trigonal bipyramidal, but when we have coordination number 5, you have two options. Okay, one can be trigonal bipyramidal geometry, so other one is square pyramidal geometry. Since here, in case of iron pentacarbonyl, we know that it has a trigonal bipyramidal geometry. Okay, and now we have to see what kind of d orbital is appropriate for hybridization to make dsp3 5 orbitals. So D here you should consider dz square, because you have 2 in the axial position and 3 in equatorial, right? It is simple dsp3 hybridization, and D should be dz square. If it is square pyramidal, okay, that is dx minus y square should be used along with s and 3p orbitals. Is that clear? Oh, okay. You are working on drug cancer improvement. Okay, so drug cancer improvement or improvement of efficiency of cancer drug, right? Yeah, good. What kind of compounds you are using? Hi, Kishore. So you have any question? Hmm. Yeah. Okay, Kishore only asked about iron pentacarbonyl. Okay, good. Yeah. Is that clear, Kishore, now? So, according to VBT, it is dsp3, d orbital is dz square. Okay, so that 5 hybrid orbitals will be 3 along plane and 2 along axial position. They will take, okay, 2 electrons each from 10 electrons are coming from 5 carbonyl groups. So you have this trigonal bipyramidal geometry with DSP3, right? So try to write MO diagram for FeCO5. Okay. So make an attempt, okay, to write MO diagram. So based on your knowledge about MCO6, okay, I think uh, in my course, I think I have shown how to write, okay, MO diagram or ligand field diagram for coordination number 6 with examples such as chromium hexacarbonyl, molybdenum hexacarbonyl. In the same way, try to write for FeCO5 and let us see how you do it. Okay. Take hint from this valence bond theory. That should tell you what orbits will be having which energy. So assignment you people are performing. So if you want to know a little bit more about this spectroscopy, you can go to my other NPTEL course, Interpretative Spectroscopy. So that should help you in understanding spectroscopy in more detail. So that will be there next semester. Okay, from January onwards, that course will open for you people. Have you taken that one in the past? Anyone of you have taken that one in the past? You have any other question? Prashant, you don't have any question? I believe you're all studying BSc, right? Or MSc? Oh, PhD in chemistry, good. Okay. Did you find this course is useful for you, Shivani? So if there are no questions, shall I wind it up or you have some more questions? I will give you another 5 minutes. If you do not have any questions, then I will wind it up this session. Then take that course also, interpretative spectroscopy. That is even more useful for you since you are doing PhD. You come across a lot of spectroscopy related problems, whether NMR, UV, visible, mass spectrometry, all those things. It certainly helps you. Okay. So if you people happen to be in Mumbai, visit IIT Bombay and chemistry department to know more about it. Why Prashant is silent? So as I said, if there are no queries or questions, okay, Prashant, Shivani and Kishore, shall I wind it up? Shall I close this session? Okay. Okay, then all the best to all of you. Do well. And as I said, if you have any difficulty, Jubilee Patel. Okay, sir, previous exam questions. Okay, previous exam questions. Uh, I don't know whether NPTEL puts on their website some questions papers of previous years. I do not know. But once you should remember, if you yes, if you need questions, what you should do is the assignment is there. We have almost 130 questions are there. Okay, so that will give you some clue about what kind of questions comes in the examination. But one thing, when you are taking NPTEL course, you should not worry about the exam. Okay, you should worry about understanding the subject. Once if you understand the subject, no matter how we ask question, you should be able to answer. So our objective is not to examine you, but educate you. But on the other hand, we should have a way of measuring your understanding level. That's the reason we conduct exam. Okay, so don't worry too much. It's not a competitive exam. Don't worry too much about questions and what kind of questions and all those things. The basic objective for you people is to learn the subject. Okay, if you learn and understand, okay, the purpose is served. Why I'm floating this is not to conduct exam and evaluate you people. Okay, my intention is to educate you people so that you can take up competitive exams with authority and come up with flying colors. Okay, so don't worry about questions. Do well. Jubilee, I hope you got it. Okay, so don't worry about exam and question papers. Try to understand, and if you do not understand any of the topics, at any stage, you can always write to me. I will try to clarify your doubts. And but understand the basics, whatever is needed. Okay, so that would stay. No matter what questions are asked, you should be able to answer with ease. Okay, once you understand, answering the question is like drinking water or eating cake. Both are very easy, right? Okay. So normally we don't, allow questions to discuss, or we don't put them on the website. But assignments will give you some hint about the type of questions that come. Okay, as I said again, I'm repeating. Please don't worry about examination. Okay, the exam is the last thing we want to do it. but our main intention is to make you learn subject. That is it. Okay. Okay, all the best to all of you. Okay, so I'm taking leave now. Again, once again, I wish you all the best. So later, whatever you want to do in your, profession, okay, my best wishes are with you people. Okay, take care. Thank you.